Hello everyone. Today we are going to discuss a software called debugger. When a program is compiled and is free from syntax errors, it generates the target code, also called the executable code. The next process is to run the software or run the program and verify whether it complies with the specification or not. This is done by giving a specified set of inputs and check whether the output is as per the required specifications or not. If the output is correct, we conclude that the software or the program is working correctly. If the output is wrong, we once again check the inputs if there is anything wrong with the input data. If the output data or result is incorrect even after providing the correct input, we conclude that an error exists in the software. Sometimes the reason for the incorrect result is obvious and easily understandable to the programmers, but at times based on the incorrect output, it is very difficult to know the exact cause of the incorrect result. The exact cause is known only by looking at the source code. Manual analysis of the source code and identifying the logical path which has led to this incorrect result is also sometimes very difficult to find out. The problem is even more complex when the code is developed by someone else and now analyzed by some other person who was not the part of the development team. In order to facilitate the easy identification of the bugs and remove them, a software tool called debugger is designed. A debugger is a software tool which facilitates the process of step-by-step execution of a program and helps to easily pinpoint the reason of a bug and the incorrect program statement causing that bug. During the process of software testing, the bugs in the software are found. These bugs are removed using the tools called debugger. These days, the debugger software is integrated part of the compiler or development environment and therefore does not need separate installation. The programs written in assembly language can be debugged using debug.exe command in the DOS prompt, in the DOS command prompt available in the Windows environment. The first step in the debugger usage is to first check whether it is installed properly on your operating system platform or not. In order to check the installation, properly study the user manual and learn the preliminary commands to access whether the installation is free from errors and does not require troubleshooting. The next task is to learn the basic debugger concepts and vocabulary. The general concepts and the vocabulary is same for all the debuggers available on the variety of integrated development environment, whether it is a C++ development environment or a Java integrated development environment. The basic concept and the vocabulary is same for all the debuggers. However, the various steps differ from the steps of operation differ from one debugger software to another. Therefore, you need to learn how to use the particular debugger that is available to you. The documentation for your debugger will help you with this task. In this session, rather than talking about a particular debugger on a particular integrated development environment of C++ or Java or any other language, we provide an introduction to the basic debugger concepts and terminology. With the strong theoretical background of the basic concepts and the terminology, it is easy to learn a new debugger available with the latest programming environment. Also, you will find the debugger's documentation easy to understand. Therefore, we start with the basic functions of a debugger software. How it works, what are its various modes of operation, how it helps to uncover errors and fix them. A debugger is defined as a piece of software that enables you to run your program in debugging mode rather than in normal mode. Running a program in debugging mode allows you to execute the program in a step-by-step mode in line after the line of the source program in the sequence unless until the sequence is changed by the statement causing the change in the flow of control. Specifically, a debugger enables you first to see the source code of each statement in your program that is under execution. Second, it is possible for you to suspend or pause the execution of a program at few marked statements of your interest. Third, while your program is paused, the debugger gives the facility through commands to examine and change the value of the variables declared in the program. Fourth, at any point you can resume or continue the execution. Debuggers are of two types, one is a console debugger and another is a visual debugger. The console debuggers come bundled with the language compiler in the form of standard libraries. It is often part of the language. These debuggers operate through a keyboard interface. When the console debugger runs, it typically opens a new window. The user can specify whether to run the program in a step-by-step fashion or execute up to a given breakpoint. The line up to which we want execution is marked as a breakpoint. A typical debugger has many ways to specify the exact places in the program where you want execution to pause. When the debugger pauses, it displays a special debugger prompt that indicates that the debugger is now waiting for the keyboard input. The user types in commands that tell the debugger what to do next. Typical commands would be to display the value of certain program variables or to continue the execution of the program. Another type is visual debugger. The visual debuggers are typically available as integrated part of a multi-featured integrated development environment or interactive development environment. A powerful and easy to use visual debugger is an important selling point for an integrated development environment. The user interface of a visual debugger typically looks like the interface of a graphical text editor. The source code is displayed on the screen in much the same way that it is displayed when you are editing it. The debugger has its own toolbar or menu with specialized debugger features, and it may have a special debugger window, that is an area to the left of the source code used for displaying symbols for breakpoints, the current line pointer and so on. The features of the debugger can be invoked by mouse clicks on the areas of the source code, the debugger margin or the debugger menus. If you are using a console debugger, then depending on the facilities offered by your particular debugger, one may start the debugger in different modes. One way may be to add an argument, for example, -d to the command line that starts the program running. For example, if the name of the debug program is debug and the name of my program is myprog, then entering the command at DOS command prompt debug -d my program will put the program in debugging mode right from the beginning. Without -d argument, the DOS command debug my program will start execution of the program. A third way may be to start the normal execution of the program until a certain line in the program, after which we may want step-by-step execution mode. If you do this, when you start your program running, it will execute normally until it reaches the debugging statements. When those statements execute, they put your program into debugging mode, and from that point on you will be in the debugging mode. If you are working with a visual debugger under an IDE, then there is usually a debug button or a menu item on your toolbar. Clicking it will start your program running in the debug mode. As the debugger runs, it visually demonstrates the step-by-step execution with the help of a visual pointer indicating what statement is under execution. Once you start the debugger, it will show you that the code for one statement in your program, execute the statement and then pause when the debugger is paused. You can tell it to do only two things: a command to print a memory variable by the command print variable name will print the value of the variable, and second, the command step executes the next statement in the sequence and then pause again. If the debugger is a console debugger, you must type these commands at the debugger prompt. On the other hand, if the debugger is a visual debugger, you can just click a next button or select one of the memory variables from the list of available or defined memory variables into a special show variable window. Although such a simple debugger is moderately useful and appeals to start with, using it you will quickly find yourself wishing for more control over where the debugger pauses and for a larger set of commands that you can execute when the debugger is paused. Many a times we are confident about the initial program modules and identify the problem area as starting from the line number n, because till from program line number 1 to n minus 1, if you are confident that the program will run without errors, and we hope for some errors only after line number n. So, instead of step by step execution till the line number n, which may be very clumsy if n is very large. Therefore, instead of starting from the beginning, we have a facility to put a breakpoint at line number n. When a breakpoint is put at the line number n, the program executes without pausing till line number n and pauses at the breakpoint so as to allow the user to run the program in step by step mode to find errors after the line number n. With the breakpoint functionality added to the debugger, you can now set a breakpoint at the beginning of the section of the code where the user expects the likely presence of the errors, then start the debugger. The debugger runs as normal until it encounters a line with a breakpoint attached to it. The breakpoint tells the debugger to pause so that the debugger pauses. Instead of step by step execution through the next command, we may jump to the next breakpoint through the next breakpoint command. That means, we can set multiple breakpoints in a program and identify the reasons of program error by quickly jumping from one breakpoint to another. Often you find the next 20 lines are free from errors and there is no point debugging these lines. While debugging the program, we often come across subroutines. Sometimes we want to start debugging from the start of the subroutine. The command step into subroutine name works for that. Then we can run each program statement of the subroutine in a step by step fashion. However, in many cases you know that there is no problem in the subroutine. In such cases, you may skip the step by step execution of the debugger by the command step over the subroutine name. That means, when we are confident that this subroutine has been tested many a number of times in other application, there is no point in testing this subroutine, there is no point in the step by step execution of the subroutine. You can skip the step by step execution of a subroutine by a command step over subroutine name. When you use step into or step out to drop down into a subroutine, it sometimes happens that you feel there is no point continuing as step by step. We can instruct the debugger to execute normally till the end of the subroutine or come out of the subroutine and execute the next statement after the subroutine. The command step out or run until subroutine and causes the program to run without pause until it encountered a return statement and then to pause. The commands step over and step into commands are useful when executing for or while loops iterating a number of times. When you encounter a looping construct, a for statement or a do while statement for instance, we can run the command step into or the step over to quickly execute the loop and identify the root causes of the bugs if present. Next, there are debuggers having features not only to view the value of the program variables, but also permit you to change the values. They also permit you to go back and rerun from a previous breakpoint. When you are running a visual debugger, the debugger may pop up with some special debugger windows with debugging information. A watch point window may show the values of your watch variables. A call stack window may show the call stack and so on. The next feature of the debuggers is the persistence feature. At the end of the workday, you are half finished till certain point in the program. Your debugger work is not yet finished. You switch off your computer and come next morning. When you start your computer again and run the debugger again with the persistent feature present in your debugger, you find that all of the aliases, breakpoints and watch points that you defined the previous day are preserved. With this feature, the debugger allows you to save the state of your current session and the debugger in a special file. This file allows you to recreate and resume from where you left in the previous day. Most debuggers allow you to create a file that contains these alias definitions. That file is given a special name, maybe some extension, and when the debugger starts, it looks for the file with that special name and automatically loads these definitions into the current session, so that you can resume the debugging from where you left the previous day. Another feature is of the debugger is that many times during debugging you are interested to find how you have reached this line of code. For example, if the main program calls a function A, it then calls function B, the function B then calls function C, and there exists a line 50 in that function C. The call stack at that moment will contain the information that at the moment you are at the line number 50 of the function C, but to reach this function C you have come from the function B, because it was the function B which is called the function C, and the function B in fact was called by the function A, and function A was called by the main program. So, your trace of the current program statement is that from the main program function A was executed, the function A called function B, the function B called function C, and from function C at the moment you are at the line number 50. That means, you have the complete trace of the current statement from the main program, and this is shown using a special window called call stack. And in short, it tells you about the parent functions till the main program on how it has reached the current statement. It helps you to find out the exact cause of the bug, as sometimes the program follows the wrong call sequence. Some debuggers allow you to attach a set of conditions to the breakpoints. You may be able to specify that the debugger should pause at the breakpoint only if a certain condition is met. For example, you can set that a condition x less than or equal to 50, or if the value of a certain variable has changed since the last time the breakpoint was encountered. You may be able, for example, to set the breakpoint to break when a certain counter reaches a value 100. This conditional breakpoint feature allows you to run a loop say 100 times before breaking. A breakpoint has a condition attached to it is called a conditional breakpoint. A breakpoint that has no condition attached to it is called an unconditional or a simple breakpoint. In some debuggers, all breakpoints have conditions attached to them, and unconditional breakpoints are simply breakpoints with a condition of true. That means, irrespective of a condition, it has to break at that point. The another important feature of the debugger is the presence of watch point. Some debuggers support a kind of breakpoint called a watch or a watch point. A watch point is a conditional breakpoint that is not associated with any particular line, but with a variable. A watch point is useful when you want to find which program statements are causing changes in this program variable. Then, without setting breakpoints at all these lines affecting the variable, one watch point is enough to do that task. And once a watch point has been defined, then it watches the variable after the execution of every program statement. Whenever the value of variable changes, the code pauses and you will probably get a message telling you why execution has paused, because particular variable which you specified in the watch point has changed. Next, you can look at where you are in the code and what the value of variable is. So, we have learnt about the watch point, which is an important feature of the debugger. So, in short, what we have learned today are the features of the debuggers like step by step execution, setting conditional and unconditional breakpoints, watch points, debugging with functions and loops was discussed. These features were explained without the specific details of a debugger in a particular integrated development environment. These features can help a novice user to quickly explore and learn the usage of a debugger in a programming environment. Thank you.